Good morning. It's my pleasure to welcome you all this fine morning. I hope all are safe and healthy. We have with us Dr. Ashish Tendulkar, machine learning architect, Google, as our chief guest. We also have our very own head of IT department, Dr. Ashish Vanmali. It has been the trend of Department of IT to conduct SDPs for the students of VCET, and this pandemic was certainly not going to stop us from doing the same. And here we are today to the inaugural ceremony of SDP on Python for data science. To brief about this program, this has been scheduled keeping in mind the courses that students have already learned in previous semesters like Python language and databases. We have planned out topics which are beyond the syllabus. We intend to cover Python language and the packages required. We shall not dive deep into machine learning at the moment, but we shall certainly do it in near future. I now request Head of the Department, Dr. Ashish Vanmali, to say a few words.
Thank you, Swati. Good morning, everyone. Today's chief guest, Mr. Ashish Tendulkar, faculty members of the department and from other departments, and all the students who are participating in SDP. On behalf of IT department, I welcome you all for the inaugural session of this student development program on Python for data science. People always ask why you need such SDPs. Actually, the goal of any graduate course to make the students industry ready. However, the syllabus that we normally have doesn't normally meet the requirements of the industry. And nowadays, when the industry recruits a student, they want that the student should have some special skills. If we don't train the students, then the possibility of their campus recruitment also reduces. Hence, keeping all these things in mind, the IT department has always planned student development programs on various topics so that the students are trained properly, they acquire the appropriate skills, and when they go for the campus recruitment or for the interviews outside, they will always have an edge on the other students. Also, these particular SDPs are focused or derived in such a way that they will always meet the requirement. And our faculty members have always taken a step forward to carry forward these things which are beyond the curriculum. Now, about this theme about Python for data science. So, as all we know, the information is growing and the impact of internet has increased tremendously. And there is a lot of data that is flowing on the net. And it is very much required that we analyze this data properly so that we take the proper decisions. As a result of this, the AICT has also included data science as an emerging course. And I'm happy to announce that our institute actually has got two courses. One that is computer science with specialization in data science, and AI with data science, which will be starting from 2020-21. So to make the students, current students aware with this latest trend and make them, uh, give them hands-on training, we have planned this particular SDB where we will be starting on Python for data science. It is going to be around 60-hour long course where there will be two things that we will conduct daily. There will be morning sessions where we will train the students, and there will be assignments or quizzes that will be given to the students. Let me tell the students that you have to do all these assignments and quizzes thoroughly, because based on how you do these assignments and quizzes, based on that we are going to award grades. Okay, so once again, welcome you all for this student development program on Python for data science. I hope all the students will get benefited by this. And before I end, I will like to thank some of my faculties. Firstly, Chandan sir, who has always behind me saying that, sir, ye karna hai, sir, ye course karna hai, sir, wo course karna hai. I want to train the students on this topic, that topic. Okay, so without his efforts, none of the student development programs could have been possible. So, lot of thanks to Chandan sir. Also, Madhvi ma'am, who has always taken keen interest in planning the things, and all the faculty members who are contributing as a speakers, or making the arrangements. Okay, so welcome all, and let's hope that this SDP will benefit all. Thank you.
Thank you, sir. I consider it my honor to introduce our chief guest, Dr. Ashish Tendulkar. He's an experienced AI ML professional with specialization in deep learning and natural language processing. He carries 18 years of experience of working in the domain of AI and machine learning. This includes 11 years of post PhD experience in multiple domains, including fintech, fashion, online media, advertising, oil and gas industry, manufacturing, IT systems, healthcare, and the list goes on. He has acted as a trusted machine learning advisor even for startups. His academic achievements are a source of motivation for us. He's the alumnus of IIT Bombay, from where he has earned his master's and doctorate degree. His publication records are testimonial to the quality of research he has been doing. He has several awards and honors to his credit. So we are truly honored to have you with us today. I now request our esteemed guest, Dr. Ashish Tendulkar, to take over and guide us.
Thank you, madam, for your kind words, and it's a pleasure to be part of this conclave. I always like to talk with students, especially the machine learning and data science aspirants, because I truly believe that this tribe should increase. What I will do is I will actually give a very short presentation, about what is machine learning and different areas and different opportunities that are out there. Okay, so let me share my screen. Is everyone able to see my screen? Yogesh sir, is my screen, Chandan, is my screen visible? Okay. Okay, so the topic of today's discussion is machine learning. My name is Ashish Tendulkar. And what we'll do is we'll talk briefly about machine learning, and I will talk about various directions that you can take in machine learning. We use machine learning in our day-to-day life. I'm sure all of you realize that, or all of you know about it. That's one of the examples. So if you're using Gmail or any other email client, you see email classification like spam and not spam. And a lot of interesting things happen. Sometimes if classification is not accurate, your useful email also goes into spam, right? Then there are recommendations. We see recommendations everywhere. If you go to Netflix or Hotstar, you will see video recommendation, or even on YouTube, right? You also get movie recommendations. If you go to Amazon, Flipkart, you get recommendation for books, products. If you go to LinkedIn or Facebook, you get recommendations for professional connections, friends, and also personalized news feeds. Right? Then if you're interacting with your mobile phone with voice commands these days, so that is also machine learning is there in the background that understand what command you are giving, and based on that it performs certain actions. Then if you're using Gmail these days, and if you type few words, the entire spelling is completed for you. That is called as predictive text, and that also uses machine learning. And search is another example. All of us cannot really stay without search engines, and search uses machine learning quite heavily in the back. So what exactly is machine learning or data science, right? Data science, machine learning, these terms are used quite interchangeably. And I'm glad that you are going to learn Python for data science in this course. So let's try to understand what machine learning is, and then I spend some time, describing what data science is and how similar and how different it is from machine learning. Now, if I ask you to write a program to add two numbers, it's very easy, right? I mean, all of you will say, "What is this?" Right? We know a lot of programming languages. Adding two numbers is, it's a child's play for us. And if you write C code, maybe 5 lines of code. If you write Python, maybe a couple of lines of code, you can write this, right? So essentially, we write the function add with two parameters A and B, and we essentially return A plus B in order to compute addition of two numbers. If I make this problem slightly more interesting and ask you to write a program to detect cat in a given image. So I'll show you some images. So can you there are two eyes, then there's a typical type of mustache, and there is a particular type of nose and mouth, then it's a cat. Fair enough, but I can always come up with counter examples where I rotate the picture of the cat, or I put cat among different animals, or I give you only side picture of the cat. Probably your program will start failing, right? But all of us, right, our brain never fails to recognize a cat, even if we see cat from a distance or from an angle. Correct? So, what is the difference between these two tasks? So, in the first task, which is addition of two numbers, we are able to compute addition of two numbers as well as we are able to spell out how to perform this addition of two numbers. Right? But in the second task, we are able to perform the task of detecting cat from a given image, but we are not able to tell the stepwise process to detect cat in the given image. Correct? And that's what separates these two tasks, and that's where machine learning enters into picture. Right? So, what is it that we are trying to do here? Given this particular photograph or the image, we are interested in detecting whether there is a cat or not. Other important difference that I would like to point out, slightly more mathematically, is that in the first problem, the function is known to you, right? Addition of two numbers, you know the function, which is a plus b. But in the second task, the function is not known to us. So machine learning does nothing but it determines the function. What is the function? This function is function of the pixels of the image that is given to you. So you are given an image which is in terms of pixel values, and based on these pixel values, you have to return 0 or 1. You will return 0 if there is no cat in the image. You will return 1 if there is a cat in the image. Right? And how does it do it? Now that's that is what is machine learning all about. So it tries to mimic the process that is there in our brain. So how did we, learn to detect the cats? So, if you recall your childhood memories, maybe your parents or your grandparents or your older or your elder brothers or sisters would have told you, right? This is a cat, and they might have given you a few examples, or they might have shown you cat a few times, and then our brain, starts, recognizing the cat. So we'll try to do exactly the same thing, where we'll make use of what is called as training data, which is images with cat annotation. So we'll use lots of images where there is a cat present in the image, and we'll essentially show these images to the computer and tell the computer that, hey, this is how the cat look like, and our job is to essentially learn the function of recognizing the cat from the image. So for that, so function is simple, right? And function can take a very simple form. The simplest function that you know is equation of line that you studied in probably high school, correct? Which is y equal to mx plus c, where m and c are the parameters, correct? So, we can come up with some function, right? We can come up with a very simple function of a linear combination of the pixel values. Let's say there are 1,000 pixels here. So we say that, whether there is a cat or not can be detected by some linear combination of the pixel, whereas you will see W1 into pixel 1, W2 into pixel 2, and you will add all these pixels together and determine whether there is a cat or not. Now, let's say you somehow come up with a function that detects whether there is a cat or not. We need to know how accurate is this function, right? So for that, we use what is called as objective function, where we try to optimize this function while learning, and we give some kind of a penalty for not detecting cat correctly, or we give a reward for detecting the cat correctly. Okay? And machine learning does nothing but optimize this cost function and gives us an. And once you have a model, the problem is as simple as addition of two numbers, because once you know the model, you essentially know the function, right? You know the function with the parameters, and then it is as good as writing the addition function, correct? So there are two steps. The first step is called as training, where we give a bunch of examples, and from that learn some kind of a function. And second is inference, where we take a new image and use the learn function to detect the cat. So I call this as a programmer-friendly definition of machine learning, because programmers are quite well versed about writing program, and this is my attempt to teach you machine learning from the programmer's perspective. Right. So there are so what is the definition of machine learning? Machine learning is a field of computer science which gives computer the ability to learn without being explicitly programmed. Now this is very interesting. We can actually make computer learn without writing a program. So you saw this in the example of cat, right? We did not really wrote the explicit program to detect the cat, but instead of that, we gave lots of examples, pictures with cats in them, and make computer learn that particular thing. This is very interesting. So there is a very famous saying: if Google is written today, we will write Google very differently. We'll use a lot of machine learning to write the Google search engine if we write it today. So which actually opens up a lot of new possibilities, and those new possibilities are very, very much you can, with your creativity, you can think of applications of. Okay. So at this point, I will actually spend some time in machine learning from data science, or describing what are the common things in that. Right. So in data science, what we do is we essentially use the past data, which is just like training data, like images of the cat, and we try to learn certain kind of functions to predict what will happen in the future. For example, if you are working in a company in the sales department, you might want to forecast what will be the sales in the next quarter, right? Or or you might be interested in detecting whether incoming transaction is a fraudulent transaction if you are working in a banking system, or if you are working as a loan officer in the bank, you might be interested in detecting whether to give a loan to a particular person, depending on the profile, right? So these are all the examples of data science tasks. So machine learning gives you the theoretical foundation for doing data science, and data science has a lot more things around it. So data science typically starts with some business problem. Nobody tells you the problem to detect the cat, right? Detect the cat from a picture. This kind of problem will not be given to you. So typically, what happens when you work in a company, in a corporate setting, the problem will come to you in the guise of a marketing task or a sales task, or it could be a user retention task, right? I mean, maybe a product manager will walk in and say that, hey, my users are dropping. What can I do to retain my users? Or what kind of offers should I be running on the platform so that my users, users stick to the platform and then they don't leave the platform. Right? So the problem will be typically described in this particular fashion to you. So there is a lot of business aspect to it, and once you understand, so then you have to collaborate, or then you have to discuss with, then you have to work closely with the product manager or sales manager or marketing manager to understand the problem, find out what kind of data sources are there in the company, and then essentially build these machine learning models. So machine learning is kind of a very it's a core part of the data science, but there are a lot of other things around the data science. And once you build this kind of a model, you have to again go back to the business and work with them to put that particular model in the production, where they'll be actively using that particular model, and you'll be getting feedback for using that particular model, which also gives you an opportunity to make the model better. Data science is all about. And there are lots of jobs in data science these days, and data science is called as one of the hottest profession of 21st century. And you must have heard terms like data is the new oil. So oil actually made a lot of money in 20th century. So countries which were having oil made a lot of money, Now, in 21st century, what they call is data is running oil. So any company that has data will essentially rule the world, because once you have data, you can actually ask very interesting kind of business questions, build model, and you can use that data for your profitability. So you can see, and we are voluntarily creating, we are voluntarily helping in creating this particular data. How? I mean, we use different apps. So different apps actually, record a lot of our interactions. Some apps also record our activities, our locations, and based on that, they are able to create a profile, and they are able to figure out, which group of individuals, work together, or work similarly, or which group we belong to, and based on that, they can actually make promotional campaigns that are tailored to our interest. Right. So that is about data science. Right. You must be wondering, I mean, whether this field is new. This field is not at all new. I mean, these concepts are around since 1950s, right? AI was first introduced in 50s, and most of these techniques that we use are quite old. But what is really changing? So AI came in 50s, machine learning came in 80s, and now you see a lot of buzz around deep learning or data science. So most of these techniques are proposed quite long back, but it was quite hard to train these systems, because the systems were so the models that are there are having very large number of parameters, and we were just not having enough training data as well as computational power to train these kind of models. But with a lot of internet companies around, and a lot of smartphones around, we are generating large amount of data, and thanks to distributed computing like cloud, there is very easy availability to large amount of compute. Based on that, we are able to train really humongous model. I'll actually give you a very interesting example of a challenge called ImageNet. So in 2012, computers were not so accurate in recognizing objects from the images. So on an ImageNet task, humans are having 5% error rate, and computers were having error rate of 26%. Now, in 2018, when scientists repeated the experiment, the computers have learned this task so well that they are doing better than humans. So humans have 5% error rate, whereas computer has error rate of only 3%. And this advancement in computer vision, based on deep learning, are kind of being used in many places. So you must have heard about using these techniques for medical diagnosis, right? So Google has come up with a system called diabetic retinopathy system to detect diabetic retinopathy. So what happens is that the image of a retina is taken with a fundus camera, and based on that image, whether a person is having diabetic retinopathy condition is determined. So so these are the advancements which are being used in lots of exciting applications. So I'll show you some more applications of um, of these models. So this is more about recognizing objects. This is detecting fraud. This is self-driving car. These techniques are also used to make the car drive on its own, which is very cool. So you don't have to work hard. You just have to go and sit in the car, and car will essentially navigate automatically. Then this is the game of Go, which is order of magnitude difficult than chess, because there are 200 moves after after every move. So the total number of board positions is more than the number of atoms in the universe. So this is considered to be one of the toughest game for computers to master. So using this computer vision technique, we Google actually trained a bot, trained an agent to play the game of Go, which managed to beat the world champion of Go not once but multiple times. All right, so these are different types of machine learning. Supervised learning, where you are given labels. So, for example, if you want to find time to go from, let's say, Vasai station to Vasai village, you will be given lots of examples of travel itineraries, and so at the end of the itinerary, you will have the travel time, you will have different conditions, you will have time of the day, you will have week of the day, and based on that, you have to predict the travel time. That's an example of regression. Or if you want to predict the housing price based on various properties of the house, that's an example of regression. Then if you want to predict whether a person has a diabetic retinopathy condition, which is essentially you want to predict 0, 1, or detect a cat, that's an example of classification. Right? Sometimes what happens is that you're not given really target, you only know a bunch of customers and you want to group them. So that grouping is called as clustering technique. Right? And then there are semi-supervised learning and reinforcement learning. Okay, so these are 5 steps to typically train a machine learning model. First is data. So it's very important to know that without data you cannot do machine learning. Remember this. If you don't take anything away, but take only this particular thing away, that will be great outcome. No data, no ML. Repeat after me: no data, no ML, or no data, no data science. So data is the important prerequisite. Then you have to clean, prepare, and manipulate the data. Then you have to train the model, test it with the unknown data, and then you keep on improving the model. Okay. So what I will do now is I will quickly show you one example of how easy it is to write these machine learning models with Python, and that might be that might be motivating for you. So here, what we are going to do is we are going to essentially run a Python program. We are going to write a Python program to detect handwritten digits. So this is an example of, this is called Google Colab, and you can write essentially your Python program in Colab and run them just like your Jupyter Notebook, which might be introduced in this session. So Colab is a tool that is used to write Python program as well as to write documentation. So there are 2 types of cells here. One is called as code cell, and second is called as text cell. In text cell, you can write the description, and in the code cell, you essentially write the code. Okay. And what I will do is I'll connect. When you say connect, some kind of a remote computer is allocated to you. So you don't have to install anything on your machine, but you connect to a cloud computer in the cloud, and then you can essentially start executing this. So I'll quickly show you how easy it is to write the program. So MNIST is a data set of handwritten digits. So there are 0 to 9 digits. So you have to essentially predict the handwritten digit. So computer, you will essentially input the image of a digit to the computer, and computer will predict what is the digit. Right? So this is, so it is in less than 10 lines of code you can write the program to detect, to train a model. So this is a model that we have added here. So in 5 lines of code we can add a model. You may not be able to make sense of this particular thing, which is okay right now. Just want to show you the ease with which you can write these kind of programs and execute it. Right? You don't also need to have huge amount of compute in your home. Google Colab is available to everyone, and you can also get GPUs, which makes it faster to train some of the models. Or you can also get TPUs, which are specialized hardware for training machine learning models. Okay, so let us quickly run the program. So we are using TensorFlow as a package to okay, and this is how I load the data. So I have training data here. I have training data and labels, and test data and the labels. I define my model here. And let us define. Let us compile the model here, and let us fit the model. Okay, so this is how I'm training the model, and you can see that as model is getting trained, our accuracy is going up. Right, so we achieved accuracy of 98%. Just in 10 lines of code, and spending few minutes of executing this. Right. So I just wanted to show this to you in order to excite you about what is possible with machine learning. So now I want to briefly talk about what kind of job prospects or areas are there in data science. I told you that data is the most important thing. So there are roles for database administrator, database designers, data engineers, and essentially these are all roles not about traditional databases but big data, because the amount of data that you are going to manage will be in gigabytes or petabytes, and there are different kind of techniques that are used or specialized tools that are used to organize the data and query the data. So there are data engineers which are required to get the data. Then there are machine learning scientists or the modelers that are required to essentially build models from this particular data. So data is fetched by data engineers, and machine learning scientist goes in, they write the data pre-processing pipeline and the model itself. And you also require software engineers to take this model and put it in production. And you understand the production system, so maybe the system that is serving to the live traffic. So for example, if you're using a mobile application and let's say you're using Google search, you type your query and then query goes to the Google server, where there are a bunch of processing that happens, right? And maybe you can include a machine learning model inside that or whatever software that you have, and use that for the production system. So there are these three different kind of areas, and when you are studying this, right? I mean, so Python is very important because there are a lot of libraries that are available for doing machine learning and data science in Python. So I would strongly encourage you to pay attention and do all the assignments of the course, because once you master Python, you'll be able to at least write the code. Now, even in data science, there are two types of people: people who understand machine learning inside out, right? I call them as theoreticians. They essentially understand the machine learning techniques not only from the programming perspective, but they also know how to what is the internal of these machine learning techniques, and how they are exactly coded, or what kind of changes that you need to make so that the technique can be adopted for your purpose. And there are other kind of people who do not understand the machine learning algorithms that well, but they can essentially code in Python. We mostly call them as machine learning developers. They will be knowing, they need to know libraries quite well, and how to essentially perform various machine learning tasks using those libraries in Python. So those are machine learning developers. And I would encourage every one of you, whenever you are developing or whenever you're writing some machine learning model, also try to get into understanding the details of that particular technique or that particular model, because that makes you more valuable machine learning developer. Okay. And then there are machine learning architect, who essentially orchestrate the entire process of what kind of features should be used, what kind of model should be used. If the model doesn't perform as per expectation, what are the next steps that needs to be taken? So all that is done by the machine learning architect. And when you're working in data science, another important thing that you need to remember is that you should have collaborative spirit, right? You should be willing to work in a team. And because you might be working with very different kind of problems, right? You might be working with different kind of domains which you may not be totally familiar with. For example, you might be working in oil and gas, right? If you're working in, let's say, oil and gas company, you might find yourself working on predicting, let's say, failure rate in some component in the refinery, right? That's a data science problem. Or at other time, you might be working in a pharmaceutical company where you might be talking about drug discovery using data science, right? Or you might be working in an agricultural company where you are trying to predict, what will be the yield of the field, or what kind of nutrients that should be given to the crop, and what will be the outcome of that, right? Or if you're working for a news company, you might be working with the textual content and writing machine learning tools to extract insight from that. right? So it's very important to be agile, willing to collaborate with people from different domains, learn the domain to an extent where you will be able to have meaningful conversations with them. So these are all important characteristics that all of you should try to develop, being an aspiring data scientist. And also you should have good communication skills, because once you get results, you should be able to communicate them back to to your collaborators, and take the feedback and incorporate that inside your model. So all these things are very important. So that's all from my side. If you have any questions, happy to take them. And I once again thank you, the organizers, and Ashish sir, Yogesh sir, Chandan sir, and Swati ma'am, for hosting me. Thank you very much.
Thank you so much, sir, for sparing your time for us and giving us the valuable insights, explaining us the concepts in detail, making us aware of so many facts and guiding us. Thank you once again. I would also like to thank the management, principal, all HODs, entire IT fraternity, all the speakers and participants for helping us in putting up this show. This SDP is certainly a wonderful addition to our calendar activities. I hope that the students will make the most out of this SDP. Stay home, stay safe, and keep learning. Thank you all for being with us. Thank you.
Thank you.
Thank you very much, everyone. The instructions for the course will be shared in the Google Classroom for the students. So all the students can go to the Google Classroom. The information will be shared with them, and they will get the forward information over there. Thank you.